Alright, our next computational method is something called Napier rods. And basically what it is, it's the galley method, except we have rods that are pre-made showing all the multiplication facts. So these would actually be separated into little sticks, also called Napier bones. In doing this, we don't have to know how to multiply anything. All we have to do is know how to add, and we can perform any multiplication. So let's give this a try. So looking at here, we have 8 times 365. So what I do is I go ahead and just take my index, and I could just use that rod right there. And then I want to take my number 365 by taking each of these rods. So we'll take a 3 here, and I'll take a 6 here, and I'll take a 5 here. Okay. Now my number then can be found by just looking at my index of 8 and looking at the resulting row. So that's really what we're doing here. We took an index of 8, and then we took our rods for 3, 6, and 5, and we have our answers to the multiplication right here that we're just going to copy down. So we have 2, 4, 4, 8, and 4, 0. The resulting answer then is just going to be found by adding along these diagonals, like we did in the galley method, and then carrying the tens to the next diagonal. So here we have 0, 4 and 8 is 12, so that's a 2 and a 1. And then 1 plus 4 plus 4, that's 9, and then we have a 2. So in this example, we get 2,920 without doing any multiplication at all. And so that's the power of the Napier rods. Now if you don't have rods, you're just going to have to basically highlight the ones that you're looking for. Okay, so the 3, the 6, and the 5, and then cross-reference that with an 8. So we have them there, and you can write them right up here before you add. Alright, so in our next one, this process will still work even with a 2-digit number times a 3-digit number. Okay, so again, we want to take our index right here, and then we want to take the rod for 7, 5, and 2. So 7, and here's a 5. Here is your 2. Okay, so next we're just going to be looking at the row with 2 and the row with 7. Okay, so first here we'll put the row for 2, and over here we'll put the row for 7. So for 2 we have 1, 4, 1, 0, and 0, 4. With 7 we have 4, 9, 3, 5, and 1, 4. And now we're just going to add up along our diagonals. So we have 4, 6, 12, and then this would be 5. Then here we have 4, 0, 5, and 1. Now there's only one other thing we have to remember, that when we went with the 2 here, this 2 was in the tens column, and so we have to add on an extra 0 to this number. So we really have 1, 5, 0, 4, 0 plus 5, 2, 6, 4. So the last thing we have to do is add these two numbers together. So we have 4, here's a 10, here's 3, here's another 10, so it's 2, and so our number becomes 20,304. And again, let's check that. 27 times 752, and we get 20,304. Okay, so the only thing new in that step was because this 2 was in the tens column here, we had to add a 0 at the end of our number. And then because it was a double-digit number, we actually had to add these two numbers together to get our final answer of 20,304. All right, I want you to give this example 3 a try on your own. Go ahead and pause the video and come on back when you're done to check your work. All right, welcome back. You can check your work here. Remember to put the 0 here, and then when you add them together, you should get 132,551. And always make sure to check your work here. So 83 times 1,597. And you can see our answers match. And again, we're able to multiply without doing any multiplication whatsoever. And so things like this are precursors to our modern day calculator, which take all the work of adding away as well. All right, so that is using Napier's rods to perform multiplication, and this is what you would need here to show your work to get your answer.